So we're going to look at adding and subtracting and multiplying polynomials. And the first thing we're going to look at is actually adding polynomials. So we're going to deal with adding. Adding polynomials is just like combining like terms. The only difference is now we're going to start throwing exponents on some of our variables, and we'll talk about how those are different. Okay. So let's just take a look. Let's just kind of review. So if, say, I had 2x plus 4x, simple combined like terms. This is an x, this is an x. We combine them together, we end up with 6x. Boom, simple. We're adding the coefficients on the like terms on the variables. All right, if I look down at the next one, all right, here we got 2x plus 3y plus 4x. Well, 2x and 4x, they are like terms, so that combines to 6x. And 3y, that's not a like term, so I'm just going to add it on. I'm just going to rewrite it. So it's like 6x plus 3y. Kind of flew through that because, again, that should hopefully be reviewed for you here. Now we're going to look at like what happens when we get to something like this. Okay. We have something like this: 4x plus 2x squared plus 3x. So if we look here, well, they all have an x variable, but the difference is this exponent. Okay. The exponent, when you say an exponent, think of it as a different variable. So the 4x and the 3x, these are like terms because they're both x to the first power. So we can combine these. So this is 4x plus 3x is 7x. And then because the x is squared, it's not a like term. So then it would be just plus 2x squared. We don't combine this. So then the boom, right there, that's our answer. So when we're adding polynomials, we add them just like when we combine like terms back in pre-algebra. And you did them a little bit in Algebra 1, Part 1. But the trick is, if there is an exponent on a variable, that is not the same as a variable without an exponent. So now let's even go further. What if we had this one right here? 3x squared plus 5x plus 7, and then plus 4x squared minus 8x plus 13. Okay, so now we're sitting here going, holy potatoes, there's a lot going on here. Yeah, there is. We got, this is a polynomial, also known as a trinomial because there's 3 terms. This is a polynomial, again, a trinomial because there's 3 terms. We're adding a trinomial and a trinomial. Right? Well, because we're adding them, I have them in parentheses. Well, when we see something like this, technically we need to distribute the operation in between. So we're going to rewrite this one without parentheses. So 3x squared plus 5x plus 7. Now, when I distribute the plus, a plus and a plus turns this into plus 4x squared. Plus and a minus turns this into negative 8x. And a plus turns this into plus 13. So now we have this big expression here. And we just combine our like terms. So if we look here, we have a 3x squared and we have a plus 4x squared. Those are like terms. We combine them together. We get 7x squared. Then, if we look here, we have a 5x and we have a minus 8x. Right? Those are like terms because they're both x to the first power. So positive 5 plus a negative 8 would give us a negative 3x. And then the last things we can combine together, all right, are the constants. We have a plus 7 and a plus 13, which combine to be plus 20. And none of these are like terms, so this is my final answer. It's 7x squared minus 3x plus 20. Okay. So we're adding polynomials, it's just like combining like terms. Okay, you're finding your like terms. If anything has an exponent, it changes it out. All right, let's look at the next thing. All right. Let's move my mug here. All right. Now what we're going to do is we're going to look at what happens when we subtract polynomials. Right? Subtracting polynomials is very similar to adding polynomials. There's just one little tweak, and you'll see here on the next example. So say I have 2x minus 4x. Well, I have 2x, and I'm subtracting 4x. So look at the coefficient. So 2 minus 4 is a negative 2. There's my answer. I just subtracted it. So now, like I said, we're going to look at see how subtraction is a little different than addition. How subtraction is different than addition. So we're running into something similar to what we just saw in our last example with addition. We have a trinomial minus a trinomial. So when we have this, if we look at this first one, we're just going to rewrite it without the parentheses. 3x squared minus 5x plus 13y. So we got rid of the parentheses because there's nothing to distribute there. The trick here is when we see this minus sign, we have to distribute that minus sign through. We're multiplying everything by -1. Or basically, you change the sign. So we have a negative and positive turns this into a negative 8x. A negative and a negative turns this into a positive 13x squared. And a negative and a positive turns this into a minus 2y. And now we go through and we combine like terms. I have a 3x squared. And I also have a positive 13x squared. 3 plus 13 is 16x squared. A negative 5x and a negative 8x. So negative, negative. So that would be negative 13x. And then we also have a positive 13y and a negative 2y, which combine to be 11. So that's it. So subtracting and adding polynomials is very similar. The only thing is when you see something like this, you have to distribute the negative sign through, or basically you change the sign of all the terms right there. And it's all just combining like terms. The only difference is when you have like an x and an x squared, those are two different terms, right? So that's adding and subtracting polynomials. The next thing we're gonna look at is what's called multiplying polynomials. Multiplying polynomials is a little bit different. Nothing too crazy. All right, so we're gonna look at multiplying polynomials. Right, we did adding, we did subtracting. Now we're gonna multiply. So when we multiply polynomials, so if I run into the following example, 2x times 4x. When I see this, I'm gonna take the coefficients, multiply them together. 2 times 4 is 8. And then I got to take x times x. Well, if you look at it, it's x to the first times x to the first. Here's exponential rules. When we multiply exponents, we add them. 1 plus 1 is 2. So this is just x squared. So 2x times 4x is 8x squared. Okay. So let's look at this next one. We have 2x times 4x squared. Well, we have 2 times 4, which is 8. I don't know what happened with my pen there. Let me erase that. It's a funny looking 8. And let me go back to my pen. So it's 8. And then we have x to the first times x squared. So x to the first times x squared. Multiplying exponents, we add. 1 plus 2 is 3. X cubed. So our answer is 8x cubed. All right, well, let's look at this one. Here, we're going to do my favorite property, SpongeBob's favorite property as well. All right, we're going to do distribution. So we're going to distribute the 2x to every single term here. So we're going to do 2 times 4, which is 8. X times x squared, which is x cubed. Then we got to take 2x times 3y. So we're going to, again, still multiply the coefficients. 2 times 3 is 6. X times y. X times y is just going to be xy. So we have 8x cubed plus 6xy. I know that doesn't look like 8x cubed, but my pen's being a little cuckoo for Cocoa Puffs. All right, and last example of multiplying. Actually, not last one. We'll have another one after this one. We have 4m squared times 7x squared m plus 10xm minus 3a. Oh my goodness gracious, there's so much going on. Just distribute. Distribute, distribute, distribute. Drawing your rainbows to remind you. Break it down by term. So let's do the coefficients first. 4 times 7, 28. Right? We have an m squared and we have an x squared. Okay, well, we're just going to rewrite x squared. Now we have m squared times m. When we multiply exponents, we add them. So 2 plus 1 is 3. So we have m cubed. Next, we're going to take 4m squared times 10xm. So 4 times 10 is 40. M squared times xm. Well, there's no x, so we're just going to rewrite x. M squared times m is just going to be m cubed. Okay. And then the last one, we're going to do 4m squared times negative 3a. Well, 4 times negative 3 is negative 12. M squared and a, well, a m squared. We're done. Okay. That's all you do. You just go through and you go term by term. Don't look at it as a whole. Break it down term by term. Okay. And last one, and this is kind of tricky, but we have covered this before. All right, multiplying a binomial times a binomial. Right? I don't know why this is on here. Let me select or delete this. There we go. All right, let's drag this back up. So we're going to multiply a binomial times a binomial. Well, it's binomial. There's two terms in this one, two terms in this one. Bi means two. Okay, so we're going to multiply them out. And we're going to do what's called double distribution. Meaning, we're going to take this 8x and we're going to multiply it to 3x. And then we're going to take the 8x and multiply it by the -6. So how we can rewrite that out is we basically have 8x times 3x minus 6. And then we also have plus 4 times, we also got to distribute this 4 to everything. So we also have minus 6 this way. So 8x times 3x, 24x squared. 8x times -6 is 48x. 4 times 3x would be 12x. And 4 times -6 is -24. Now, if we look, we go, okay, all right, I did that. Good, I multiplied. Well, now we got to go back to the addition subtraction part. Do I have any like terms? Well, if we look here, okay, 24x squared. Is there any other x squared? No, there's not. So I'm just going to rewrite it. 24x squared. Next, -48x. Is there another x? Yes, there is. There's a positive 12x. So what's -48 plus 12? Well, that would give me -36x. -24 has no friends to join with, and boom, we're done. Look at that. So we turn 8x plus 4 times 3x minus 6, okay, by doing what's called double distribution. Now, when you have a binomial times a binomial, you can use what I've referenced before, which is called FOIL. So I've got the same exact problem. We're going to use FOIL, right? And FOIL, F-O-I-L, in FOIL means first. So we're going to take the first term times the first term. So 8x times 3x is 24x squared. Then the O stands for outside. So we're going to take the two outside terms, and we're going to multiply these two together. All right, so 8x times -6 is going to give us -48x. Next, we're going to go to I. I is inside. So we're going to take the two inside terms, and we're going to multiply these two together. 4 times 3x. They're both positive, so it's positive 12x. And then the last one on FOIL, F-O-I-L, first, outside, inside, last, meaning we're going to take the last two terms in both binomials and multiply them together. 4 times 6 is 24, positive and negative makes it a -24. And now we just combine like terms. 24x squared minus 36x minus 24. Same answer. Yeah. But again, FOIL only works when you're dealing with a binomial times a binomial. It does not work with any of the other. It only works with binomial times binomial. All right. All righty then. Hopefully that was good. Hopefully you got your notes done.